Hello, I am Josh Dowen from the United Kingdom Without Incineration Network, and this is our workshop on municipal waste incinerator greenhouse gas assessments. So who are UKWIN? So they were founded in 2007 with the support of Friends of the Earth, and they are the only national UK-wide network supporting local anti-incineration campaigns and campaigners. There are currently around 50 local groups with whom we are working, and together with our members, we have helped prevent more than 100 incinerators. We work nationally to inform waste and resource policies and decisions, and importantly for today, we help debunk greenwash. And we maintain a website at ukwin.org.uk with lots of useful information. So, how does the incineration industry like to portray incineration? They firstly don't use the term incineration. They usually use euphemisms such as energy from waste plants. And they say things like energy from waste plants are turning trash into power. And this is one example of such a promotional material with sun shining and everyone happy, and where they say that they provide sustainable waste disposal for communities while generating clean, renewable energy. And this is from a YouTube video trying to explain how great it is, which has more than 17,000 views on YouTube. So do we agree with their framing? Not really. They miss out a big part of how the waste is turned into energy. And that's a bit scientific, but it's important to understand what it actually means to turn waste into energy. So as part of the combustion process, the oxygen combines with carbon to form CO2. So the air joins with the carbon in the waste, and any hydrogen mixes with the oxygen to form water. And these reactions release heat, which is used for energy. So it is the process of converting carbon into carbon dioxide, which is actually what is turning waste into energy. And in that sense, the creation of CO2 isn't the byproduct, it is the main show, with the energy generation actually being a byproduct of that chemical process. And so the amount of heat that is produced depends on the carbon content of the waste and the hydrogen content of the waste. And the CO2 emissions come from the carbon content. Now, the CO2 that comes from sources such as food, paper, and wood are considered by governments and others, generally speaking, to be biogenic CO2, with the energy being referred to as renewable energy. Now, we know you not necessarily agree with that description, but in many countries, that is how it is considered for the purpose of renewable energy targets and so on. Whereas the plastic that is incinerated is a fossil fuel, and its CO2 is considered fossil CO2. And so often when operators talk about the CO2 that they release, they actually only talk about the fossil CO2 and they ignore the biogenic CO2 altogether. So this is the actual process. So if you have a mixed waste feedstock and you're burning it in an incinerator, then typically around 27% of that feedstock will be carbon. Now, conveniently or coincidentally, that is the same proportion of carbon to oxygen, C to CO2. And so 1 ton of waste, generally speaking, results in 1 ton of carbon dioxide. And around half of this is considered fossil CO2 because it's from plastics, and half of it is considered biogenic CO2 because it is from wood waste, etc. And the heat byproduct, which is converted into energy, is considered, at least by the UK government, to be partially renewable because of the biogenic element. But actually, most of the heat isn't used in a typical incinerator. In a typical electricity-only incinerator, maybe only around 23% of the kind of energy within the feedstock is actually converted into electricity. Now, if we look at dense plastic, there's a lot more carbon in there, and so there's a lot more CO2. So a ton of dense plastic is around 48% carbon, which means it creates around 2 tons of fossil-derived carbon dioxide, and all of the energy is considered non-renewable or fossil-based energy. So it is literally a fossil fuel, but is actually combusted at lower efficiencies than other forms of fossil energy, such as CCGT gas, which means it creates more carbon dioxide per unit of energy produced. So we wanted to highlight this impact of incineration that the operators usually don't talk about. So we published a report in October 2018, which is on our website, ukwin.org.uk/climate. And what this talks about is how incinerators usually release around 1 ton of CO2 per ton incinerated. We explain that. We explain how it's usually higher than gas. We explain how when waste is landfilled, a large proportion of the carbon is stored underground. When incinerated, the carbon is converted into CO2 and released into the atmosphere. And how over its lifetime, a typical new incinerator built in the United Kingdom would release around 1.6 million tons of carbon dioxide equivalent more than sending the same waste to landfill, even when methane is taken into account. And that's why it's called CO2 equivalent, because it's converting the methane into an equivalent amount of CO2 based on the assumed global warming potential of that methane over a specific time period. So it's trying to express it in a way that makes it more comparable. We also mentioned how most of what's actually being incinerated in the United Kingdom could be recycled or composted, which means actually comparing incineration and landfill isn't necessarily a very good idea anyway. But we released this report and it did get a lot of attention, but incinerator operators still made a lot of the same claims afterwards that they were making before about how great incineration was. And so we followed it up with good practice guidance for assessing the greenhouse gas impacts of waste incineration, which we released in July 2021. And this is simultaneously talking about good practice of how you can assess greenhouse gas impacts, but it also serves as a bit of a guide to debunking greenwash claims, because it talks about the good practice to some extent as an alternative to the bad practice. And we also released a blog post in August of this year, which I wrote with Flomo, which went with the headline, "Guide warns incinerator GHG emissions often worse than predicted," because that is one of the main findings and thrusts of the guidance. So there are 5 key findings with respect to the discrepancies between the theoretical performance that incinerator applicants just talk about during the planning and permitting phases when they're trying to get permission for the plant and trying to get funding for it and so on, and the real world performance of actual incinerators when they looked at what they were emitting. The first finding that we had, and if you see this is only for 2 different incinerators, because the actual number of incinerators in the UK that reported on their real world emissions was very low. And so we didn't have much to choose from. So effectively, at the time we wrote the report, this was, you could say, a full data set of all the incinerators where they had that information available. And what we found was that the proportion of the carbon dioxide that was fossil CO2 was typically, when you look at the incinerators, 13 percentage points higher than they were predicted at the planning and permitting stage. And what that means is that operators conveniently said, oh, don't worry about our carbon dioxide, most of it will be biogenic anyway, and therefore you shouldn't count it. But actually, it turned out that a lot more of it than they were predicting turned out to be fossil CO2, which is derived from gas and oil, which is a fossil fuel, and so that their predictions were, you could say, optimistic. We found a similar issue in relation to what they predicted in relation to the carbon intensity of the electricity exported, and that is how much CO2 is released per unit of energy exported to the grid. And so they claimed there was a much lower level than it actually was. And now, actually, the amount that they claimed wasn't particularly great, but the amount that was actually reported was much worse. And so we found that the fossil carbon intensity of the electricity exported to the grid was around 49% higher than they had predicted. So that means they might have said it would be around 610, and it turns out to be 852. Or if they said it was around 394, it turned out it was around 828 grams of CO2 equivalent per kilowatt hour. So it turns out that the extent to which the facilities were high carbon was much greater than even they were previously admitting. We also looked at the predicted and reported kilograms of fossil CO2 per ton of waste feedstock incinerated. So ignoring the amount of energy it was generated, how much carbon of that was fossil carbon was in the waste. And again, we found that the amount was much higher than they had claimed at the planning and permitting stage. In fact, we found it was 20% higher than what was predicted. So more fossil CO2 for every single ton that they burned. We also looked into the performance across all of the incinerators in England, the electricity-only incinerators, and compared it to what their headline generation capacity, also known as the kind of plated capacity. So they may have said that this is a 10 megawatt incinerator, and that means that that's how much energy it should be generating, however many hours it's operating. While it's operating, it should be generating that much energy. But we looked at the actual amount that they exported to grid, which all incinerator operators are required to report to the Environment Agency. And if you look at the averages for each facility, the amount that they actually generated was 15% lower than their headline megawatt generation figure. So they're actually generating a lot less energy than they said that they would. And the amount that they export was 28% lower than that headline generation capacity. So the energy that was used to run the plant, what's known as the parasitic load, was a significant proportion of the energy that they actually generated. And so the amount we generating was low, the amount they actually exported to the grid, net of what they imported and they used to run it, it made it even worse. So actually these facilities aren't particularly great at generating energy, even compared to the claims of the applicants themselves. So as part of the report, we came up with 10 key recommendations for the incinerator greenhouse gas assessments that are carried out in relation to incineration. So that could be assessment, whether it's assessments carried out by government or assessments carried out by incinerator operators wanting to oppose an incinerator. We came with 10 recommendations that we thought would be helpful. And I'm going to go through those recommendations and provide some real world examples of how we have made use of those recommendations and of why those recommendations were useful for us to create in the first place, kind of some of the origin stories. So the first recommendation is in relation to the topic of transparency. And that's how we do the report. We break into lots of different topics. And it's that the methodology and modeling assumptions, including the underlying data and how it was derived, should be transparent and verifiable. And the scrutiny of environmental claims made to support waste incineration should be facilitated rather than frustrated. Now, you might think that these things are so obvious you don't even need to say it, but actually, for many incinerator applications, they don't provide a lot of their assumptions. And even when asked to provide a lot of their assumptions, they often don't do so. So it's a very important one that we can point to when people aren't giving all the information they should. And here is an example of why it is useful for them to be transparent and what it can show when they are. So in the North London Heat and Power project, they did an assessment of the climate change impacts. A consultant was brought in to carry out this assessment, and they did a reasonably good job of being transparent about how they came up with their resulting figures. And one of the things that we found when we were looking into it was that they claimed two different things. One is that the waste composition is as provided by the applicant for residual municipal waste. So the applicant told them what they expected to be burning at the incinerator, and that a net calorific value of residual waste of 10 gigajoules per ton has been specified by the applicant. And then they say, effectively in their report, that those two numbers don't line up. When they looked at how much energy was in the waste that was specified by the applicant, they found it was 8.54 megajoules per kilogram, but the applicant said it should be assumed that it is 10 megajoules per kilogram. So rather than going back to the applicant and say, you can never get that much energy out of that much waste, they effectively said, okay, so we assume that they kind of pro-rated it up. So by a certain percentage point, they just assumed that more energy was obtainable from that waste than was in that waste feedstock in the first place. Now, I don't think that that's a very good way of doing it, but they were transparent. So they said this is how much energy you can normally get out of plastic, but we're assuming that you can get more. And so at least they were transparent. Many applicants have their assumed composition for the purpose of how much carbon is released, and they have it and then they have the assumed energy generation, and they don't match, and you don't know that these two don't match because they're not as transparent about it. So that feeds into recommendation 2, which is, okay, we'll give you points of being transparent, but actually they should match. So we say that the recommendation 2 in relation to the impact of waste composition and technology on energy and greenhouse gas outputs, we recommend that key outputs such as power exported and greenhouse gas emissions are dependent on waste composition and the processes used, and that when modeling future emissions, it's necessary to ensure that the outputs are internally consistent with inputs. So if in effect a lot of the energy comes from the carbon itself, you can't assume a different amount of carbon than the amount of energy. It doesn't work. And that's why we have that recommendation. And here, an example of us using that recommendation in our report and citing it is in a report that we've recently written for a 1.2 million tons per annum incinerator in Boston that's being proposed. That's one of the largest incinerators in the UK, and yet they don't, in that report, show how their waste composition and their GHG outputs correlate. They have one assessment of one for another. They might be consistent, they might not be consistent. We don't know because they don't actually explain the process. And so we complain about that within our objection, where we talk about how one of the key parameters is for evaluating the climate impact of the composition of the feedstock and the specific type of waste impacts on how much energy is generated, how much is fossil and biogenic CO2 is released, and how much waste can be processed. So, and usually you start from the composition and figure out how much energy and carbon you can get out of it, but they didn't show that they'd done that. And so we complained about that, which goes against both recommendations 1 and 2. Recommendation 3 of the report, and obviously for each of these recommendations, we give a lot more underlying detail about it within the report itself. We talk about how greenhouse gas impacts can be highly sensitive to waste composition, and that waste composition assumptions should be justified and sensitivity analysis should be used to show the impact of future changes such as increase from food and biowaste collections. That goes back to what we were talking about earlier, where as more food is collected and other biowaste such as garden waste and textiles, that changes the assessment and the results of incineration on its own, but also incineration compared to landfill. And so we want not just to look at where things currently are, but where we expect things to be in the future. And so one example we give of this within our report is the work that we did back in 2018 for the report that we did on the impacts of waste incineration in the United Kingdom, where we found that incineration was always worse than landfill, but how much worse it was than landfill did depend on the feedstock, where if you had less plastics, then incineration was closer to landfill. If you had reduced compostables, which therefore meant more plastics, then incineration was even worse compared to landfill. And so that was based on 265,000 tons of waste, which was kind of the size of a typical incinerator at the time. And so we have lots of examples of other people doing other assessments that came to similar conclusions, not specifically about how much worse incineration was than landfill, but about how the impact of changes in composition are important and therefore need to be taken into account. Now, recommendation 4 goes into some of the other issues we've already touched upon, which is that while heat export, carbon capture, and pre-treatment to remove plastics prior to incineration can potentially reduce the overall greenhouse gas impacts of incineration, there are also uncertainties regarding the deliverability and overall impacts of those options. And we go into that within the report. But one of the things we also do in the report is we give lots and lots of references to other reports, which people can then go to as well. And there is also, in relation to carbon capture and storage, a report recently released by Zero Waste Europe, which covers a lot of issues in relation to carbon capture and storage. And then other organisations, such as Friends of the Earth Scotland, have also covered issues in relation to carbon capture and storage. And so we do mention that there are various issues in relation to those things that are kind of put forward by the incineration industry and others as something that will kind of solve the problem of incinerator greenhouse gas impacts. And we can say it doesn't necessarily solve that problem, and it might cause new problems. So you have to be careful when you're doing it, but you can take into account, because obviously if there's also the element where if there's a proposal that doesn't do these things, you can also ask the question, is this proposal worse than a proposal that did these things? And so you can take it into account, and that's where sensitivity and life cycle analysis can be used to explore a range of possibilities and to reflect relevant uncertainties. So you can say, if this were the case, it would be this, if not. And so sensitivity analysis is effectively where you look at your kind of key parameters and look at how changing those parameters would impact on the key results of the assessment. And that's something that we call for a lot of the time, because we want a broad range of potential impacts to be considered, because there is a lot of uncertainty to these assessments. And usually when applicants are looking at it, their assumptions are in their favor. And so if you look at a wider range, usually that ends up making for a more balanced assessment. The 5th recommendation is moving on to a different topic, which is the role of landfill as a biogenic carbon sink. And that means by carbon sink, what we mean is something that stores carbon. And it's generally accepted that in relation to plastic, incineration acts as a carbon sink, because if you put plastic into landfill, it doesn't rot down, because plastic doesn't rot down compared to incineration where it's released. But in relation to the biogenic material, especially things like wood waste, it's also, a lot of it doesn't rot down. And so we note that to produce a valid comparison when comparing waste treatment options such as landfill incineration that release different quantities of biogenic CO2, it is necessary to account for these differences, especially the impact of the biogenic carbon sink in landfill. So even if your view is that the release of biogenic CO2 from incineration is carbon neutral, that should then lead to the conclusion that to avoid that release by storing it in landfill is a carbon saving, because it's acting as a carbon sink. So even if you think it's carbon neutral, you should still consider it when comparing landfill and incineration with one another. And that is something that DEFRA, the Department for Environment, Food and Rural Affairs in the United Kingdom government, acknowledged as far back as February 2014, when they said that this is a report for DEFRA, that the model that they did to assess the carbon-based modelling impacts of different sequestration options assumed that not all biogenic material decomposes in landfill, was converted into CO2 in energy from waste. And so they assumed it wouldn't all be converted into methane, or CO2, and that therefore means it's a partial carbon sink for the biogenic carbon. And they acknowledge that was a potential additional benefit for landfill over energy from waste. Now, in that particular report, they didn't have it in their main assessment, they had it in their sensitivity analysis, where they did acknowledge it as a potential additional benefit. And they actually gave two ways of taking into account this additional effect, method 1 and method 2. So method 1 was to account for all of this CO2 and the sequestered biogenic carbon. And so what they said was you can estimate the amount of biogenic carbon sequestered and you'll include the CO2 produced from the same amount of carbon in the incineration side of the model, also subtracted from the landfill side. So effectively what they're saying there is do it in the old-fashioned way of ignoring, of only focusing on fossil CO2, and then add just the sequestered biogenic carbon onto one as either as a saving of landfill or as an opportunity cost of incineration, and that they said would help address the failure to count it if you only focus on the fossil CO2. And the other is to include all carbon emissions on both sides of the equation, which means you count all the biogenic CO2 emitted by incineration and all of the lesser amount of biogenic CO2 released by landfill. And they listed those two methods. And actually, whether it's method 1 or method 2, between them, a lot of organizations have made use, have taken into account the biogenic carbon sink either as part of their main assessment or in sensitivity analysis. So that includes environmental groups such as UKWIN, Zero Waste Europe, and Client Earth in various reports looking at the impacts of different waste management options. It includes governments and governmental organizations and reports produced for or by them, including the European Commission a report which fed into some of their waste policy, in the Greater London Authority in their report for their EPS Ready Reckoner guidance, and in the United States, the EPA, the Environmental Protection Agency's waste reduction model, known as WARM, that they use for assessing the impacts of distant waste management options, and indeed in the greenhouse gas inventory reporting by the US government. So in America, what they actually do is take account of all of the biogenic carbon sink benefits of landfill within their emissions reporting, and they base that on the IPCC guidance in their National Greenhouse Gas Inventory workbook, which states that ultimately each country should report all important sources and sinks of all greenhouse gases, and they considered it to be an important sink. And so they report it, and we talk about that more in our report. Academics use it, which is the EASE waste model, which is used by the Technical University of Denmark. And we talk about that and about some of the academics behind that, and the academic papers that they wrote on it, and all the various other academics who have cited it all. We only go into some of them, but it is within the academic literature and peer-reviewed papers and so on. And even incineration companies have taken into account this impact of landfill acting as a biogenic carbon sink being a benefit over incineration. So it was taken as a benefit by Uniper for their Merg incinerator, by North Lincolnshire Green Energy Park for their facility. And we go into more details about those in our report. And those, they do it effectively as part of their kind of sensitivity analysis and kind of more overarching look rather than their main assessment. But actually, in relation to the Ratty's Lane incinerator, it was actually part of the main assessment. They took it into account, but you wouldn't actually know that from the initial documents that they submitted, because they didn't actually give all their calculations. So we actually only found that out when we asked for the spreadsheets and got the spreadsheets. which goes back to Recognition 1, where sometimes they're doing a good thing and you wouldn't necessarily know about it unless they are transparent. And that actually helps sets a useful precedent for other facilities that if some operators are doing it, they should all be doing it because it has been established. And here is an example taken from the report that we do, but just the kind of edited highlights of the impacts of a few different materials. And if you take into account the fact that there is this biogenic CO2 released from incinerators that would be avoided if it was landfill. And in this example, is added to the incineration side of the equation. So if you look at this is the gross CO2 released per ton of waste stream processed, expressed as CO2 equivalent. So it includes the methane as it's released as well. And this is the landfill from textiles, because of the fact that half of the textiles roughly is plastic and half is natural fibers, which is biogenic. So there is some emissions there, but textiles don't rot down as much as some wastes. So if you take into account in incineration just the fossil CO2, that's worse than landfill. But if you take into account the fact that a lot of the biogenic material in the textiles is stuff, the natural fibers don't really rot down very much, then actually the emissions from incineration are way higher for textiles. In relation to miscellaneous combustibles, you get a similar story, and that's a mix of fossil and biogenic CO2, what is classified as miscellaneous combustibles, where incineration is worse than landfill without taking into account the biogenic CO2 that is sequestered. But if you take it into account, it makes incineration a lot worse. Wood, there's no CO2, there's no fossil CO2 in wood. So if you ignored the sequestered biogenic CO2, you'd think that incineration for wood is way better than landfill. But actually, if you take into account the biogenic CO2 that is sequestered, burning wood becomes not a very good idea in relation to the gross CO2 emissions. Now, there's also the impact of different levels of energy generation, and we come to that later, which has a kind of a diminishing role as the electricity supply decarbonizes. But just in terms of the gross CO2 equivalent emissions, this is based on government data in relation to those emissions. Waste wood isn't very good for incinerators. And then similar with sanitary disposable nappies, a lot of that ends up not being converted into methane and therefore being sequestered in landfill. But that means if you ignore the difference in biogenic CO2 releases, it makes incineration look a lot better than it actually is. So for a lot of feedstocks, there's a big difference to if you do or don't include it. And then a lot of those who want to promote incineration end up not including it, then kind of gives a distorted picture. So we give one example we have several examples in the report of actually correcting for this. So because they often say, they're often transparent about how much CO2, how much biogenic carbon is sequestered as part of their assumptions, you can convert the biogenic carbon sequestered into avoided biogenic CO2 because we know the ratio of C to CO2, as noted earlier. And so what we sometimes do is correct it for them and effectively send that to the waste planning authority or the decision maker and say, if this is taken into account, it shows that the facility is worse. So one example we give here for the Ford incinerator is that if you look at just the figures from the applicant, at different rates of landfill gas capture and different rates of electricity generation offset for the credit given for the CO2 avoided from the energy generated from other source of energy that wouldn't have to be generated if the energy was exported by the incinerator. For all of their scenarios, they said it had a positive impact. Admittedly, in some cases, only a marginally positive impact. Whereas when we took into account the impact of biogenic CO2 being not emitted from landfill, that being a sink, it turned all of them to be negative, apart from the kind of worst case scenario that are the highest displacement factor in the and the lowest level of landfill gas capture rate assumptions, where incineration is only marginally better than landfill. So it can make a big difference to the results of such assessments, because that's what we found. And we set that out in a report. An example of where we set this out as well more recently is in the Boston objection. We cited the recommendations and the guidance and explained how that wasn't taken into account by the applicant and how it ought to be. Now, moving on to recommendation 6, that is in the topic of the discrepancies between the theoretical and real-world performance of incinerators. That is one that we've covered already, so I won't go too much into recommendation 6, which is that the carbon performance of modern waste incinerators is often significantly worse than was predicted through modelling at the planning and permitting stages. And we went through how much worse that was earlier. And that the discrepancy between predicted and actual carbon performance needs to be taken into account when modelling, and robust sensitivity analysis is needed to ensure that the CO2 equivalent emissions from incinerators are not significantly underestimated, which is what we found that they often are. And then recommendation 7 is in relation to how the power export underperformance, for example, due to turbine or generator failure or during commissioning, is a realistic prospect for modern waste incinerators that needs to be taken into account when modelling anticipated power output and climate change impact. And those could be for various reasons, but during the lifetime of a 25 to 30 year incinerator, a year of a facility not operating could have a big impact on its overall emissions, as could multiple shorter downtime. And what we did in the report was we looked at a number of incidents where incinerators weren't operating, and we looked at the fact that for those, when they weren't operating, those facilities, their actual turbine was operating maybe 8% of the time, only 21% of the time, or none of the time, despite the fact that they were combusting a lot of waste. So what we found is that even when the turbine wasn't operating or the generator wasn't operating and they weren't converting any waste into energy, they were only converting waste into CO2, they were still operating. They didn't shut them down. The Environment Agency didn't shut them down. They allowed them to operate for weeks or months on end without generating any energy whatsoever. And so that's something that we found that needs to be taken into account. And we also looked at across all of the incinerators in the UK, for what proportion of the year they were operating and for what proportion of the year the turbine was operating. We found that roughly incinerators were operational on average for 90% of the year in terms of the hours, and the turbine was operational for only 82% of the year, which means that 10% of the time, these incinerators aren't exporting any electricity. But it's often the case that when they are doing the assessments, they're assuming that whenever they're operating, they're exporting electricity. And that's something that we point out, for example, in our most recent Boston objection, that the operator claimed that it was a 102 megawatt of electricity plant, but they didn't say it's 110 or 115 megawatts, and we assume that it won't be doing that all the time, so it's only 102. They said 102. And so what we're assuming is that that actually means on average, it might only be generating around 86.7 megawatts. And that means it'll only be exporting around 64.7 megawatts because it uses quite a lot of energy to power the plants. And so we've made that argument. And what we do when we make that argument is refer back to our guidance and the evidence within that guidance. Now, the next topic that we cover, and we're on recommendation 8 of 10, so we're getting close to the end of these, is displacing other sources of electricity and or heat. And that's the topic. And what we recommend in recommendation 8 is that when considering the carbon intensity, which is the amount of CO2 released per unit of energy generated, of displaced energy, it is necessary to take into account of the progressive decarbonization of the energy supply, rather than simply assume that a new energy source will displace fossil fuels, such as CCGT. And we explained that the carbon intensity or electricity displaced by a new incinerator can be estimated, and we argue or probably should be estimated, using the BEIS, which is government long-run marginal emissions factor, over the lifetime of the plant. And that's the figure that the government uses for their own internal modeling to estimate the benefit of reduced energy demand, which could be by reducing the demand for new energy by producing additional electricity. And we have evidence that that would be a good proxy for what would be displaced by incineration. And so we created this graph, and for this presentation, I've added the CCGT, which is gas generation, to it to show what it means for the decarbonisation. So it shows that back in 2010, it was assumed that if you were displacing electricity through new generation, the government were assuming that that would be on par with gas generation, and then that goes down and down and down. What that is, in order to get very low indeed, it gets towards zero, as it were, as more of the energy is generated from solar power and wind power and so on. And the UK grid average is also expected to get lower. But incinerator operators assumed, rather than what they're displacing getting lower and lower and lower, it to be stay at the 350 for gas, or actually sometimes they even assume that gas will be even worse than 350. And so when they do this, we make the complaint by drawing on our evidence. So again, drawing on Boston, we complained that they assumed that it would be displacing CCGT, the 371 figure, throughout its entire lifetime. And we argue that that is not appropriate. Now, the next topic that we cover within the report is what we call the waste treatment comparator or counterfactual. So incinerator operators like to say, well, if this weren't sent to incineration, it would be sent untreated to landfill, and that is bad because it would generate methane, et cetera, et cetera. Now, while we have evidence that sending it untreated to landfill isn't as bad as operators claim, we don't accept that it's actually a binary choice. So what we say in our recommendation is that when considering how waste would be treated if it were not sent to an incinerator, account should be taken of the prospect that it might otherwise have been reduced, reused, recycled, or composted, and account should also be made of how landfill waste could be biostabilized to reduce methane emissions. As in, even if it were sent to landfill, it could be sent to a landfill in a way that would minimize the emissions rather than sending it untreated to landfill. So going on the first part of the recommendation, which is the fact that it could be recycled or composted, it sets out in the report there is actually really government research done by WRAP for the government, which shows that between 74.5% and 80% of the residual waste stream could have been recycled or composted. And so in relation to household waste, what they found was that 53% of what's in the residual waste feedstock at the moment is readily recyclable. That means the majority, based on existing capacity, existing facilities, etc. That means effectively people put it in the wrong bin. And therefore, investment in waste education and better labeling and increased consistency so that people can be more confident about what is recyclable could effectively, it could easily halve what is currently going to landfill and incineration at a stroke. They also found that around 27% is potentially recyclable if we increased the amount of materials that can be accepted for recycling based on current knowledge about what could be recycled if we put the resources into it. Then they also found that around 12% is potentially substitutable, meaning it's a material that can't be readily recycled, but the product could be changed, so it could be a product that could be made out of material that can be recycled, so it's potentially substitutable. And they found that they only identified 8% of the residual waste stream, which is difficult to recycle or substitute. And that is 8%, not of the total waste stream, of the residual waste stream. And they didn't even say how much of that was even combustible. And there were similar findings in relation to commercial and industrial waste in Wales, where they found that 74.5% was recyclable compostable and only 23.5% was not currently recyclable, again, raising questions about how much of that could potentially be substitutable or recyclable if they improve what can be recycled. So that means that the idea that it's a binary choice between incineration and landfill is way off the mark. And obviously it raises questions about, if you keep building lots more incinerators, are you locking out the ability to have recycling in the future, etc. So we kind of reject that binary choice. But then there's also the question about the impact of landfill itself. And what the government, what DEFRA said back in 2011 was that using mechanical and biological treatment to extract recyclables from the residual waste stream before landfill, and effectively to use aerobic digestion to convert the material that would otherwise be methane into biogenic CO2, so that what is landfill would be biostabilized, which means it would be stable and wouldn't produce methane. Then actually, if you do that MBT process and send it to landfill, and based on research that the government was citing that had been done by Eunomia, the government reckoned that that would have lower impacts than sending the same waste to incineration, even incineration with combined heat and power. And that's what the government was saying back in 2011, at the same time as the 2011 waste review. And the government has never gone back on that. They've never said that they've changed their mind. And that was a report which recommended that the government ought to do something about it, but to date, the government hasn't. But there are other reports that are more recent that come to similar conclusions. So we have a report from Zero Waste Europe that was released back in January, which is when they released the kind of version of it with more information, where if you look at what the area circled in black, and I added just for this presentation a green line showing how that compares with the other forms of generation, what had the lowest level of CO2 impacts, if you're taking into account the biogenic CO2 emissions as you ought to, is MRBT, which is material recovery and biological treatment, which is basically MBT landfill, but with a greater focus on maximizing the extraction of recyclable material and biostabilizing the waste, whereas MBT usually is used as a euphemism for MBT to produce refuse-derived fuel for incineration. So it's kind of to distinguish MBT that's producing refuse-derived fuel, to MRBT, which is trying to maximize recyclables with the residues going to landfill. And they found that MRBT combines biological treatment and sorting equipment allows to stabilize the organics they've included in residual waste so as to minimize the impact once buried in a landfill, while also helping to recover materials such as metals, plastic, paper that's still included in residual waste after separate collection. But despite there being studies that show this has one of the lowest levels of impact, when people talk about incineration in landfill, they usually don't take this into account as a potential option. And there was a similar report released by Zero Waste Scotland, which is a organisation funded partially by the Scottish government, which found that there was a large potential savings from biostabilisation, which indicates this option warrants further consideration. Now, one of the things that they highlighted in that report was that at present, the kind of landfill tax system, etc., isn't set up to kind of reward biostabilization, which means at the moment there isn't the kind of financial incentives to do that. But obviously, we can foresee in the future that those financial incentives will be made available as there is a move towards net zero and so on. As we try and decarbonize the various sectors, we're trying to encourage or require biostabilization of waste prior to landfill. So to assume that if you didn't go incineration for the next 25 to 30 years, it would just be sent straight to landfill with no efforts at all to reduce the greenhouse gas impacts, we think is unrealistic. So the green line isn't a baseline. The green line is a line that I just created for this presentation to show you what the level of MRBT is compared to the other options. So what you can see is that incineration against coal, why would you assume that incineration was displacing energy generated from coal when we're moving away from coal anyway? It's better than that. It's better than incineration, than landfill displacing coal, incineration displacing gas, incineration displacing a kind of a lower carbon mix, better than landfill on its own. It's slightly better than what they call MWS plus incineration, which is assuming that all of the plastics would be removed before you incinerated it, which would reduce the fossil CO2 emissions, but also assuming that it would all of those plastics could be recycled, which we don't necessarily agree that it is possible to achieve 100% recycling of plastics, or that operators would do that, but assuming that that happened, it's still better for MRBT and much cheaper than spending all that money on an incinerator, about the lock-in effect. So it's worse than that, and cheaper than doing MWS, which is removing various recyclables and then landfilling it without first biostabilizing it. So what it's showing there is the green line shows that MRBT, if you take into account the biogenic CO2 emissions, was found to be effectively the lowest carbon waste treatment option for residual waste by that study. And obviously, we much prefer recycling to either incineration or landfill, but it does counter the narrative that we have to go for incineration because it is better than landfill. So it is kind of putting paid to that greenwash. They're similar from Zero Waste Scotland. There was also a report for Client Earth, which had a similar finding in relation to showing that landfill plus pre-sort and biostabilization had lower impacts than sending waste straight to incineration or straight to landfill. And similar, if you spend all that money to build an incinerator and then spend even more money to remove all the plastics, as it were, it would be kind of on par with that, based on the assumptions used in that report. And so that we kind of go more into details in that within our full report. This is just kind of a summary of those different reports, which all came to similar conclusions that aren't flattering for the current industry approach of sending all waste straight to incineration and claiming it's the best option around. And that does somewhat feed into recommendation 10, which is on the topic of low carbon claims, where we argue that energy from mixed waste incineration should not be described as low carbon because it involves the direct release of significant quantities of CO2, and indeed significant quantities of fossil CO2. So even if you're just looking at the fossil CO2, it's still not low carbon. And we go into a lot of detail of that in the report, but just to summarize that, we created a chart which compared the real world reported emissions of various incinerators, and which is the Bennington, Runcorn, Ardee, and Runcorn, based on the actual emissions from them, which showed that they had emissions carbon intensity of between 848 and 874, and TCGT is only 340, or if you believe some of the industry, 370, and the marginals much lower, 258, 205, and going down as the years go on. And then renewables are almost zero, or up to 42 if you look at it within this perspective of counting all the emissions from the construction. We also added Corey Riverside Incinerator because they did a report back in around 2017, where they did waste composition analysis and did did an assessment based on the assumed CO2 of each element of that material that they found in the composition analysis and the amount of electricity that they generated, which isn't necessarily as accurate as actually counting all of the CO2 as it comes out the chimney, but it's still indicative. And even that was still significantly higher than the carbon intensity of CCGT and other options. So to say it's low carbon, these emissions here, this is just the fossil CO2. So even if you look at just the fossil CO2 emissions, it's not low carbon. And this is before you take into account any of the biogenic CO2 that would be sequestered at landfill, etc. So we give various quotes from other people saying similar things. And one of the people who we quote on that is the Climate Change Committee, also known as the Committee on Climate Change, who in their 2020 progress report to the United Kingdom Parliament, who they have a legal obligation to make reports to, they said that achieving significant emission reductions in the waste sector requires a step change towards a circular economy, moving away from landfill incineration and associated emission of fossil CO2 emissions, and towards a reduction in waste arising and collection of separate valuable resources for reuse and recycling is applied at local, regional, and national levels. And actually, as we note in our report, elsewhere in this Committee on Climate Change CCC report, they specifically list incineration, unabated incineration, as they call it, which is incineration without carbon capture and storage, as a form of high carbon activity. So they say it's a high carbon activity that we should be moving away as we're moving towards a circular economy. They're not saying we ought to be building more and more of them. And we use this, for example, in our objection for the Portland incinerator proposed by Powerfuel Portland Limited, where we give the example that they said it would be low carbon, and then we refer back to our guidance as saying, actually, if you look at the CO2 emissions, it shouldn't be considered a low carbon source of energy. And so that's an example of us making use of our own report to help make that point.